Problem 13 is a relative velocity problem. We're told a pilot flies a plane 600 kilometers due north and arrives in 2 hours. We can figure out the speed that this is by simply dividing the distance by the time it took the pilot. We'll call this the velocity of the pilot with respect to ground, and that's equal to 600 kilometers in 2 hours, or more simply, 300 kilometers per hour. The plane, though, has a velocity relative to air of 400 kilometers per hour, and that's directed 70 degrees north of east, which would look like this, where this is at an angle of 70 degrees, and we'll label this vector VPA, and that's equal to 400 kilometers per hour. We're asked, what is the magnitude of the velocity of air with respect to ground that would allow our pilot to actually fly in a straight line? So that would be a vector that looks like this. To figure out the magnitude of this vector, we first need to figure out its components. Based on the diagram, we see that the x components of VAG must cancel the x components of VPA because the resulting vector, VPG, does not have any x component. So our x components must cancel. For the y components, the y component of VPA plus the y component of VAG must add up to the vector VPG, which is only in the y direction. These two ideas will allow us to calculate the x and y components of VAG, and then from there we can find the magnitude. So let's look at the first part where the x components must cancel. So VAG x must be equal to VPA x. And this one is pretty easy because we're told the overall magnitude of VPA is 400 kilometers per hour. We're actually told the angle that it's flying at, so to get the x component, we just need to find the cosine. So VPAX is equal to VPA cosine of 70 degrees. And this overall product is equal to 136.8 kilometers per hour. For our y components to add to VPG, we just need to write a simple equation. VPG is equal to the y component of VPA plus the y component of VAG. We can rearrange this equation to solve for the y component of VAG, which will be equal to VPG minus VPAY. VPAY is equal to VPA, sine of the angle that it's traveling at, which we know, and now we can plug in numbers. VPG is equal to 300 kilometers per hour minus 400 kilometers per hour times sine of 70 degrees. The numerical answer of this is negative 75.88 kilometers per hour, and with the x and y components, we can now find the velocity of the air with respect to ground using the Pythagorean theorem. Plugging in numbers, we have 136.8 squared, negative 75.88 squared, everything square rooted, to find that the velocity of air with respect to ground's magnitude is equal to 156.4 kilometers per hour, which is answer A. Problem 14 is a vector problem where we're given vector A in component form and vector B in terms of magnitude and direction, and we need to figure out what their sum is. It's easiest to add vectors when they're in component form, so our first step is going to be finding the components of B. We can find the x component of B using cosine, and the y component of B using sine. If we plug in the numbers given, for each of these, we're able to calculate the components of B. So that at this point, now we can add the components of A to the components of B to figure out the components of vector C, to find components of C, where Cx is equal to Ax plus Bx. Ax is negative 4.7, Bx is 0.444 for this value of Cx, and Cy is equal to the y components of A and B added together. Plugging in those numbers, we get this as the y component of C. And now, at this point, we can find the magnitude of vector C using the Pythagorean theorem. Plugging in numbers to get a final result of 9.31, which is answer E. Problem 15 gives us a velocity versus time graph and asks us how much distance is traveled between t equals 4 and t equals 16 seconds. The way to find the distance traveled on a velocity versus time graph is to find the area under the curve. So we want to know what is the area between t equals 4 seconds and t equals 16 seconds. The easiest way to do this is to break this up into little rectangles and other shapes. So I see one rectangle here and another rectangle here, along with a right triangle. Given that the axis goes up by 2's for both our y and our x, we can find that the area of just one square is equal to length times width, or 2 times 2 gives us 4. And in this area of interest, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 squares, each of area A, And then we just need to find the area of that right triangle using 1/2 base times height. The base has a length of 2. The height has a length of 2 plus 2 gives us 4. And if I were to multiply all of this out, I'd get 76 meters for answer C.